Hello everyone, our Facebook friends. I'm Maria and I am here at the Tijuana Estuary and you are tuned in for Lunchtime Live. I'll wait to see if my audience is here. If anyone is here before I officially start. And it is a beautiful day here at the Tijuana Estuary. I see some folks coming in. It just burned off, so the sky is blue. It literally just burned off. And we have, the ants are with us today. We have the sun with us, the blue sky, the helicopters, the wind, and some construction noise with us today for Lunchtime Live. So we've got a full house for Lunchtime Live. A lot to contend with, but I am off trail and I am practicing my social distancing and wearing my face covering, but I'm off trail, so I won't be interacting with anyone. And I have disinfected my equipment and washed my hands thoroughly and practicing all of the protocols as we continue to move through this challenging time together. And as access increases, these things are more important to follow, more important than ever. So we'll just give it another minute or two. Hi there, hi Judy. Our trails are not crowded, and yes, people from my observation are observing social distancing and wearing masks for the most part, but our trails have not been crowded. They have remained open for the most part, almost like 99% of them throughout this time. Our visitor center still remains closed. Our parking lot and restrooms still remain closed. But stay tuned as State Parks is increasing access. We will eventually and hopefully open those as well. So we appreciate if you do come down to follow all the social distancing and mask wearing requirements that will be posted and that have been posted. So hi Mark, nice to see you. Nice to see everyone there, and we will go ahead and get started with today's Lunchtime Live, the Saltmarsh series. And today we're going to be getting into this dynamic life in a dynamic environment. And the idea of this Saltmarsh series is to have maybe 3 or 4 of these programs as we explore the salt marsh. And the purpose of today's program is to introduce the salt marsh to you, to our Facebook friends, to our audience, because not everyone knows what a salt marsh is. So again, I'm Maria, and I'm an interpreter and education specialist and research assistant here at the Tijuana River National Estuarine Research Reserve, or Tijuana Estuary for short. And you are Facebook friends, you know us, and hopefully most of you have been here before, but if not, again, I'm off trail and I am very close to the visitor center in an area we call the tidal linkage along the edge here. And behind me, a couple blocks away, you might see there those houses, those buildings. Those are along Seacoast Drive. They are right on the beach there, so just a couple blocks away is the beach, and I'm on the very north end of the research reserve. So for those of you might already know this. We'll back up. We won't start with what is a salt marsh, but first we might be wondering what exactly is an estuary. And thank you, Judy. We love our estuary too, and I love these to be interactive. So if you feel like sharing or asking questions as I move through this, I appreciate them. I will try to pause. There might be a small delay. Oh, one thing I always forget. Sound check. Everybody can hear me all right? We do have the wind with us. We do have the helicopters. I do believe the microphone is working well. If anyone can't hear me, I appreciate the feedback, or can hear me, I appreciate the feedback. All right, so I think everyone can hear me. So what exactly, thanks Judy, thanks for the thumbs up, loud and clear, great, okay. I know there's a little delay there, so if I'm pausing, it's because I'm waiting for replies. And so if you're just tuning in, you're here for Saltmarsh series, life in a dynamic environment. What exactly is a salt marsh? What exactly is an estuary? Well, you might just, know that our name is the Tijuana Estuary, but what exactly is an estuary? Well, an estuary is a type of wetland. And a wetland, anyone know what a wetland might be or want to guess what a wetland is? If you're thinking it's where the land is wet, you're right. So wetlands are places where land is wet most of the time, or a significant portion of the time, and they can come in all shapes and sizes. Hi everyone, hi Joe, hi Kate. Nice to see everyone there. So wetlands are places where land is wet, and they come in different shapes and sizes and forms. And an estuary is just one type of wetland. So a wetland can be a mangrove, it can be a river area, a riparian area, it can be around, it can be a swamp, it can be a bog. Okay, but an estuary is one type of wetland. And what makes an estuary an estuary? What makes it the type of wetland that it is? Well, an estuary is where freshwater and saltwater come together. So you have freshwater and saltwater coming together, unlike some wetlands might only be fresh. And inland, an estuary is a coastal wetland where freshwater and saltwater come together. And how does that happen? How does that happen? So I mentioned we are 2 blocks away from Seacoast Drive. For those of you who know Imperial Beach, you'll know that the beach is just 2 blocks away. Our large saltwater source, the Pacific Ocean. Okay? And freshwater, where would the freshwater come from that makes up this estuary? Well, it's the Tijuana River, the freshwater from the river that flows from the inland, from the upper parts of the watershed, and meets that Pacific Ocean, mixes with the, very good, rivers empties into the ocean, yes. So the river empties into the Pacific Ocean here, actually about, I don't know, a mile or so away, where that actual connection happens that we call a river mouth, that creates this coastal wetland that we call an estuary. So for those of you who are more poetic, you could say that an estuary is where the river meets the sea. And in our case, this specific estuary, it's where the Tijuana River meets the Pacific Ocean, okay, and creates this lovely saltmarsh estuary. All right, it's not freshwaters. So saltmarsh estuaries are these coastal meadows, and I'm standing next to a small section of saltmarsh habitat. We have a lot more. You might be able to see behind me between Seacoast Drive. There's the band of green. That's a large section of saltmarsh habitat that makes up this coastal wetland, and that is from that saltwater influence. Saltwater meets freshwater through the river mouth, creating this mostly saline or salty coastal wetland, giving it that name, a salt marsh. So it's like a coastal meadow that's flooded but regularly by salt water. And how does that happen? How does that happen? Does salt water get into this estuary, into this coastal plain? Well, it's the driving tides. It's the tides that come in, that fill this place up like a bathtub and then drain it out. So these coastal areas are influenced by the tides, high tide and low tide. And if we've all experienced tides at the beach, you know that the tides can change, that we have low tide and high tide. And if you can see this channel here behind me, as we move through our program this morning or this afternoon, you may see it to start to fill, because we are approaching our lowest high tide of today. Get back to that. Yes, we are I believe we are the largest in San Diego County coastal wetland, right? And what makes us a bit unique is that you can't drive through our coastal wetlands. So we have several coastal wetlands between here and Orange County, and you can drive through all of them. However, not here. So so this salt water coming in from the ocean through those tides, those high tides and low tides, filling and draining this system. Now, we experience here in this part of the world 2 high tides and 2 low tides a day. And I mentioned that we are approaching the lowest of the 2 high tides today. Okay? And it's about a 4-foot tide. So for those of you who pay attention to tide, because maybe you swim or surf at the beach, and you're looking for those optimal conditions for your recreation, you may be paying attention to that. So there you have 2 high tides and 2 low tides a day. And this channel where I'm standing is pretty far from the river mouth, for those of you who know this place. So if you're tuning in now or you're watching later, we are on the very north end along what's called the tidal linkage, very close to the visitor center here at the Tijuana estuary. And so this channel here, which is actually a restoration project, so this channel here this bit of Saltmarsh here is relatively new, in the sense that it was created in 1998. But I won't talk about restoration today. But so this bit of Saltmarsh here is as far as you can get from that river mouth, that place where the salt water enters into this Saltmarsh estuary and fills this place up. So at the beach, when it's high tide, it takes a little while for the tide to fill up this channel. So I believe the high tide's at 12:30. However, we may see it increasing till about 1:30 or so. It's about an hour delay. So the environment here, this constant coming in and the filling up and draining of this coastal wetland, okay, makes this a dynamic system. Hi, Judy. A couple of Judys on there. Hi. Yes, and Ridgeway rails, the salt marsh is their habitat. Very good. Yeah, so this makes this a dynamic system. That, for those of you, again, we hopefully all have experienced what tides are like, high tides and low tides, and that swing can be great. And that high tides, the high tides each day are not the same. So there's this constant flow and draining of water filling this place up, making this what we call a dynamic environment, always changing, filling up and draining out. However, there's a constant in that change, in that, again, if you understand tides, they are predictable. Okay? They are created, in a sense, by the sun and the moon and gravitational pull and a complicated a system of physics there, but not so complicated that we don't know what we can't predict them. They're very predictable. So there is a constant change. The daily change is constant, and the species living here then are living in this ever-changing environment. However, there's a constant to that change. So what might be changing? this place is filling up and draining, and it's filling up pretty good today. So are the channels natural? It's a good question. So most of them are. I don't know if you mean this, I meant this is a restoration project. So this channel was actually created, but yeah, the scouring of channels is a natural phenomenon. What happens with that ebb and flow of water. So water is a powerful force, and it scours out these path of least resistance, and it scours out these channels, finds ways, that force of water to come in, okay, as that tide is being pulled in to find ways to move. And it creates this very wet community, the Saltmarsh, filled with mostly charged. So very good. And so salinity changes. Yeah, so if you imagine being a saltmarsh species, especially maybe an aquatic one, things are going to change for you throughout the day as this ebb and flow of tide water comes in. And as water comes in, the salinity can change. It is salt water. Water is filling in, but it's also evaporating when we have warm conditions. So salinity can change. Salinity can change as fresh water comes in. Okay? However, there's not a lot of fresh water in our coastal Southern California coastal wetlands. Our rivers are very small, so they're predominantly saltwater, giving it that name, that salt marsh. If you go to a coastal wetland in, let's say, Florida, where the rivers are a lot bigger and it rains a lot more, your salt marshes aren't salt marshes. They might be more freshwater marshes and have more brackish water. So in this coastal, if you're a salt marsh species, and especially an aquatic one, you're going to have more than just salinity changes. You're going to have actually the amount of water that you can be in, the level of the water, or the volume of the water that you reside will change. Okay? And that volume of water that is made up of oxygen. So oxygen can change in this environment. The temperature can change. The temperature can change. I see a question here. I'm going to pause for a minute. Can the channels shift though? Yes, channels are shifting as the flow of tides through storm events, through wave action, through rainy years and drought years, the channels can shift. Our river mouth shifts continually. And right now it's the most southern it's ever been. Open river mouths like ours, because we don't have a way to drive through the estuary. We don't have anything blocking our river mouth or forcing our river mouth to stay in one section. It can meander. So it's always shifting, unless there's some barrier that prevents it from doing so. So in the channel, in the water, you've got your oxygen, you've got your temperature, you've got your salinity, okay, that are all changing. The turbidity, that's like the cloudiness of water as water fills up and drains out. You know? And so then these species, those species living in that dynamic environment, have adaptations to dealing with those daily environmental changes. If you're a fish, you may be able to swim out. If you can't handle low oxygen as the tide decreases and not a lot of water, you may be able to swim out quickly. Or maybe you have an adaptation that allows you to thrive and survive during a low tide, when oxygen and temperature are changing and salinity are changing. And you can hang out till that next high tide. And I'll back up. If we have 2 high tides and 2 low tides a day, how often do they change? Do we have anybody out there that knows the tide cycles? The daily tide cycles? Roughly every 6 hours. Every 6 hours. Not exactly, because then the tides would be at the same time every day, and they're not. So it's roughly every 6 hours. Very good, Mark. Every 6 hours. Sorry, I should wait a little longer for those delays there. Okay. So those tides, if you look at a tide calendar, are roughly every 6 hours. However, there's a time in the month where it does kind of flatten out a little bit. Yep. Twice, 2 high tides and 2 low tides a day. And when you're around the full moon, very good, 4 times, exactly. 2 highs, 2 lows. So there's a swing roughly every 6 hours, 4 times a day. That's a lot. That's a lot to endure when temperature and oxygen and salinity and pH and all the parameters of water that a species would require and may have a particular threshold for is affected. So, but again, these daily swings 4 times a day are predictable. They're constant. So through evolution, species have evolved to those swings, whether they have to move or they have evolved to have a way to manage, to adapt, to get through that period where those factors have increased or decreased. Lower oxygen, higher temperature, lower temperature. Could you imagine? It's pretty shallow. It's a very shallow environment. And at high tide, at a really high tide, which by the way, these new moons and full moons are when the tide swings are bigger. So are higher, the high tides are even higher than they are in the other parts of the month. And then there's a seasonal change as well. So our winter swings are even bigger. Our high tides are high, our low tides are low. That's why tide pooling has better opportunities for that in the winter time. Okay? And our king tides, where we see flooding of these systems and sometimes into our streets, occur in those winter. So here in our summer months, the swings aren't quite as big, but they do occur. And like we can see now, this channel really is filling up. And I'm standing on the edge at the very, very high tide line. Okay, I'm not in the marsh here, not in the salt marsh here. So these species, these aquatic species, the fish, the invertebrates, they've evolved with these adaptations to these swings, these big swings. Now, the salt marsh species that we will explore in subsequent programs, or this is the introduction. So if you're here today for Saltmarsh, the Saltmarsh series, Life in a Dynamic Environment, this is really the setting, the stage, the environment, understanding this environment. And then in 2 or 3 other programs, we will dig a little deeper and explore particular species. But we're going to do this with the plant community, the Saltmarsh plant community. And so let's think about how the Saltmarsh plants here might deal with this dynamic system. What are they enduring? Well, as you can see through this channel here, do we have amphibious fish? No. We do have mudsuckers that can live in very low oxygen when the tide is super low. We do have those, but I would not necessarily call those amphibious exactly. However, they can live out of water for a while. Good question. So this channel behind me here looks relatively, if you're thinking flat, that's what I'm trying to say here. It looks relatively flat. However, you may notice, and I am going to do something. I'm going to flip the camera around here and show you what I'm looking at, which is the other end of the channel, of the tidal linkage. And you can see there that on the sides, on the outer edges of the salt marsh, the elevation is just a little bit higher. It is higher. Like I said, I'm standing on the edge. If I were standing 6 feet in to the marsh, I would be wet. I would be starting to sink a little bit. And if I was in the middle of the channel, I would probably be to my knees, having sunk, even though it's very shallow. It's extremely wet and muddy. So we can see there that it's a relatively flat community. Relatively flat, however, there is some sloping there on the edges. So the marsh, the salt marsh, does have what we call an elevation change. So there is a slight elevation change. No, it's not the Sierra Nevada mountains. It's not Cuyamaca. It is a slight elevation change, but it is one that's important to understand. And you can see very distinctly, can you see very distinctly the high tide line? I bet you can. And the salt marsh right now is really looking, it's got that great bright green color. And when you can see where that ends, the habitat type changes. We get into our coastal sage scrub, our transition into coastal sage scrub, with much of what Southern California is dominated by. If you can see that change, give me a thumbs up. We can see that change there. Yes, this is very good. The species change drastically as soon as they get out of the high marsh. And we're going to talk about that. That elevation change, that drastic change isn't an accident. Okay? It isn't an accident. The species change. The habit, the coastal sage scrub you can see there is more bushy, shrubs, okay? A lot drier looking right now, a lot less of that bright green. And the soil, the ground is very dry, unlike the salt marsh. So, behind me there, you can see as well behind me on the other side, that change in elevation. So again, this is a small area of salt marsh, and that salt marsh to the west of me, out between this area and Seacoast Drive, some of the largest area of salt marsh we have here. It looks extremely flat out there, and it is. However, again, there is that elevation change, and that elevation change, sorry, I'm time out, is a question about restoration. Well, I will consider that. It wasn't something I had thought of, but I will consider that. Maybe we can bring in someone who's more versed on that, so you guys aren't just looking at me. So, great question, thank you. And I wanted to talk a little bit about this elevation change, in that the plants that are living in the salt marsh, they're adapted even to those elevation changes. So we call this area, we call this elevation change, and the plants living in them zonation. So like I had mentioned, I'm standing on the edge of the high marsh. So our zonation, really, the terms aren't too technical. We call it low marsh along the edge of the channel, mid marsh when it gets a little higher, and then high marsh. And so those areas are, which are influenced by the tide, are not influenced equally. High tide coming in fills that channel, and the low marsh area would say every high tide, maybe even to the mid marsh. Okay, but this upper high marsh area may not, depending on which high tide it is of the day and the time of year, may not get that influence of tide. It may not get wet, leaving salt water there drying out. So these plants living in the salt marsh are experiencing this influence of salt water, okay, but not equally. So some of them are inundated or flooded all the time at all the high tides, and some only get the high tide maybe during certain times of the month at the extreme tides. Okay? And in some areas, maybe not even only a certain time of year at the king tides. Okay? And so what does that mean for the salt marsh plants living here? Now, so let's think about that. What does that mean for the salt marsh plants living here? What dynamic and what environmental conditions specifically are they experiencing increases and decreases of? Right? And let me ask you guys, who thinks that salt marsh plants need that salt water to live? Do we think that these salt marsh plants need salt water to live? A lot of people think that they do, but that's not the case. Salt marsh plants don't need salt water to live. In fact, they could grow just fine in fresh water. But what they have and what they've evolved to do is to deal with that salt water, that influence of salt water, whether it's daily, twice a day, right? Or maybe, or just certain times of the year. Yes, they are what we call halophytes. They are salt tolerant. So they can deal with the salt. That's why there's that distinct difference between the salt marsh and the transition coastal sage scrub. But they are, because those plants in the coastal sage scrub, a lot of the ones that we've covered, all the ones that we've covered through previous Lunchtime lives, would not be able to live here. They don't have a way to deal with that salt water. And just like we don't have the ability to drink salt water, because we aren't adapted for it, neither does the coastal sage scrub. However, salt marsh plants do. They have the ability to deal with the high salinity. And the salinity here, by the way, is as high as the salinity of the ocean, 35 parts per thousand. The freshwater influence that creates this coastal wetland, this estuary, is so small, is so minimal that it doesn't change the salinity unless it's a really rainy season. we've had a big rain event. But during the summer especially, when very little water is flowing, and you have warm days and a lot of evaporation, you have high salinity here, sometimes even higher than that of the ocean for just brief periods. Okay, so these plants are dealing with that salt. So there's an observation here. I can't see it all. That it's hard to see a difference between the high and low marsh, and they do look very right now kind of homogeneous. However, that's because all the plants here living in a salt marsh plant community, they're all relatively, this is a generalized statement, about the same size. In the coastal sage scrub, we've got shrubs that get 20 feet high, 30 feet high, but some that stay 3 or 4 feet high. Out here, there's not that big of a difference. Some get, yes, there are some that are very small, we don't see them. There's also not a lot of diversity in species, meaning there are a lot less species on the salt marsh plant list than there are in the coastal sage scrub, because it's hard to live out here. And living and dealing with salt means you don't grow quite as high. And there are not a lot of species that can do that. Now, how do they do that? How do they deal with that salt? And we're going to explore this more specifically with examples in some upcoming Lunchtime Lives. But for now, I will describe the couple of methods, the two methods that salt marsh plants have evolved with to deal with high salinity. First method is that, or one method, I shouldn't say it's the first, one method is that some salt marsh plants have the ability to store that salt water in specialized cavities, maybe cells, these special cavities within the plant tissue, where the plant can move the salt water into, storing it there for a while, which then doesn't impact the rest of the plant, and the plant can thrive with the salt contained, in a sense, in a special area. And plants that do this, we call them accumulators. They're in the category of adaptation that we call accumulators. So these species that do this accumulate that salt water. However, will eventually, when it's full, they will eventually drop those pieces. Okay, so they accumulate in specialized cells. And as you might imagine, any plant that might accumulate something, a lot like a cactus, okay, they're a little more thick and swollen, so to speak. And again, that's hard to differentiate unless you get up close, just from looking at. I'm sure you guys are tired of looking at me, so we'll go back to this side of the channel. And you can see that it would be hard to distinguish plants that are accumulators, because everything there really does sort of generally look about the same. However, there are some plants that have another method for adaptation. And we can see this a little bit more behind me. You might be able to see some grass out there. Someone mentioned earlier the ridgeway rail. So that grass that's blowing in the wind along the edge of the channel there, that's our cordgrass. And this is an example of one of the species that has a different method for dealing with salt, a different adaptation. So plants, either they store or accumulate, or they do the opposite. They take in that salt water through their roots just like the accumulators. However, they excrete. Excrete is that fancy word for sweat or perspire, right? So we excrete when our bodies are, we have an adaptation for dealing with being too hot with high temperature, is we excrete water to cool our bodies down. We call that sweat through pores, right? Well, plants in the salt marsh, that they have an adaptation to do the same thing. However, they're moving that salt water out because they don't have cavities to store it. So their method is to release it through their leaves, through pores in their leaves, excreting it out. And sometimes we can see those salt crystals once that water has evaporated. It's salt water on the outside of the leaf, water evaporates, we see salt crystals. So in a salt marsh, for survival in this dynamic system, remember, you don't need salt water to live. You just have to have a way to deal with it. And there are, just like there are 2 high tides and 2 low tides a day, there are 2 adaptations for dealing with salt. You're either an accumulator, where you store it, or you're an excreter, where you get rid of it. Accumulators or excreters. You're either one or the other. You can't be both. And they have very different characteristics because of their adaptations. And again, you're here for Lunchtime Live. You're here for the Saltmarsh series. This is the one to sort of set the stage. And then in subsequent programs, we will get up close and take a look at some of those accumulators and excreters as we explore the dynamic environment and what it means to live here and how you survive in a salt marsh if you're a plant. Okay? So I hope you guys had a good time today. Learned some things maybe that you didn't know about the salt marsh, or what you did know was reinforced, and you got the nice look here today. I enjoy bringing these programs to you. I do look forward to this, even though this is a challenging time and it's a lot, maybe in some ways more fun to do this in person and be more interactive. I appreciate the questions and comments. You can continue to ask them once the program has ended in the comments of the program later, and I will get back to you with those. Feel free to share that anything that you have with regards to salt marshes in your community where you are. Maybe there's one that lives nearby. I'm just reading your comments right now, and it's a little distracting. I really appreciate this. I thank you for tuning in and being here, and please look for the subsequent series, subsequent programs in this series as we get more up close and personal with some of these particular salt marsh plants. So have a great rest of the day, and we will see you again for Lunchtime Live. Thank you, Facebook friends. Have a great day.